sorry, good people. Back. Someone from municipality for meter reading. Right. So that is d cubed x to the power of x power 4 plus that. So it means we take that derivative of that. Let's do that. So what is the first derivative of that one? Is 4x cubed. That's the first one. Once more, it's what? It's 12x squared. Once more, that will be 24x what? X squared. And then next one, the first derivative there is 6x. Once more, it's 12x. Once more, it's what? It's 12. The other one will be all zeros. Let's check this one. I think this one here, it's 24x. So that is all what it means. So that derivative, the fourth derivative, the first derivative, we can go up to infinity. And that example will be d squared plus d plus 2 acting on what? Sine 2x. Sine 2x. This can be rewritten as d on that, d squared on that, d on that, and then 2 on that. So this can be written as d squared on what? On sine 2x plus d on what? On sine 2x again. And well, 2 on that just multiplies that. 2 on what? On sine 2x. Are you still there, good people?
Yes.
Okay, now d squared on that, it means the second derivative of sine 2x. First derivative is 2 cos 2x. Once more is what? It's minus 4 what? Minus 4 sine 2x plus. First derivative there is what? It's 2 cos what? Cos 2x. Now 2 on that, 2 multiplies that is just 2 what? Sine 2x. If they are like terms, this together with that, that will give us, that is 2 cos 2x. If I start with a positive 1, minus what? Minus 2 what? Sine 2x. So that is how we operate. That is how we handle out operator D. Let us have more examples based on that. What about number 4? 1 over d on
Sorry,
what?
sir.
Yes, on sine 2x. Yes.
Lapha kuyi-answer leya u-minus 4 sin 2x bangisam include the final answer.
Angizange like terms. This is similar to that.
Oh,
Yes. Now 1 over d. What does 1 over d means? It means we integrate. We integrate sine 2x. What is the integral of sine? It's minus. There's 2x here. It will come out as half. It's half what? Cos 2x. What will be number 5? 1 over d squared of e to the power 4x. This means what? You integrate twice. You integrate twice. What is the integral of e to the power 4x? It's 1. It's 1. In other words, you can write this as 1 over d, then integrate for the first time. Integral of e to the power 4x. It's e to the power 4x over what? Over 4. Once more, integrate that one. I'll get another 4 coming out. That will be 1 over 16. Sorry, 16 e to the power 4x. When using this notation, good people, we are integrating. You are expected to have a c, but this notation says you may as well leave out a c. Don't include a c when we are using this notation. Ignore c, which is a constant of what? Of integration, because we are using this notation. So this notation allows us not to include c. But under normal circumstances, if it was the usual integration, then we're going to introduce c. But using this notation here, operator D method, we leave out the constant of integration. What about this one? We have 1 over d into 2x squared plus 5 plus 2 over x. We integrate that. We can do it by inspection. What is the integral of 2x squared? So it's 1 over d on that, 1 over d on that, 1 over d on that. By inspection, integral of 2x squared, it is going to be 2x cubed over 3 plus integral of 5 with respect to x, and anyway, it's going to be 5x because that 5 is a constant. Integral of 2 over x, this is the same as 2 times 1 over x. That will be what? 2 ln of what? Ln of x. No c. We don't put a constant c here. What about the next one? The next one says we integrate, I think it's number 7, 1 over d squared into 3x squared plus what? Plus sine 2x. What does that mean? It tells us we integrate it twice. Let's do it by inspection. For the first one, integral of 3x squared is 3x cubed over 3, which is x cubed. Once more, it is what? It is x to the power 4 over what? Over 4 plus integral of sine 2x twice. The first one, it's minus cos 2x over 2. Once more, it's minus 1 over what? Over 4 what? Cos what? Cos 2x. That is all what it means. So 1 over d, integrate. D means differentiate. But things, good people, will not always be as easy as they seem to be here. What about when we are asked to work out the following? Work out the following, an example. So what about when we are asked to evaluate 1 over d plus 1 acting, let's say it's acting on x squared. Now, takes a different shape now. So what is it that we know right now? We know d as well as 1 over d. But from that one, we don't have that. We don't have 1 over d, and we don't have d. So that is not proper there. In other words, it's not in our standard notation or format. So that is not standard. So by the way, this can be written as 1 over 1 plus d, or on what? On x squared. This is not in its standard format. Standard format will be d or 1 over d, because d means differentiate. 1 over d, integrate. So we need to work out that first until it talks to x squared. Mind you, this can be written as 1 plus d to the power minus 1 on what? On x squared. That is the meaning of that. Having said that, remember S1, we can expand that. We can expand that using what is called binomial expansion. Let me take a pause here. Now, remember, that's one. Note, if you've got a plus b to the power 2, we'll get a squared plus 2ab plus b squared. What if we've got a plus b to the power minus 1 or minus 2, or whatever the case might be? Then in this case, we use what? Binomial expansion. Binomial expansion. I hope you did this at S1. Binomial expansion, whereby a plus b to the power n is a to the power n plus n a to the power n minus 1 times b plus n minus 1 a to the power n minus 2 times b squared over what? Over 2 factorial plus, look at the pattern, n into n minus 1 into n minus 2
Sorry, sir.
A,
May I ask which
yes.
topic are we in?
Come again?
Which topic are we doing right now?
Yes, its chapter is operator D methods.
Operator D method. Okay, thanks, sir.
Yes, operator D method. So now, if you can, if you are given A plus B to the power n, it's easy when n is 2, when n is 1. But when n is it's 7, it becomes very tedious and it's not easy to find the answer direct. So we use what is called binomial expansion. So in other words, if I were to take you back from here, therefore 1 plus d to the power minus 1, using this binomial expansion on x squared, it will be equal to, let me expand that now. My n is minus 1, my a is 1, my d is b. So I'm applying it then. So my a, there is a, which is 1, to the power what? To the power minus 1, plus, next one, it's n, which is minus 1, to the times a is 1, to the power what? N minus 1 times what? Times b. My b is d. Next one, plus. Next one, plus is minus 1, which is this n, into n, it's minus 1. A is 1, to the power n is minus 1, minus 2, times b, my b, it's d, that is d squared, all over what? 2 factorial, plus, let's carry on there, even though there's no need now. It's n, it's minus 1, it's n, it's minus 1, it's what? It's n minus 2, it's minus 1, minus 2, a, it's 1, to the power minus 1, minus 3, d cubed, all over 3 factorial, plus dot, 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 dot. We can carry on like that. If you simplify this thing, good people, it gives us 1 minus d plus d squared minus d cubed plus d to the power 4. Perhaps you can give me the next terms there. So in other words, 1 plus d to the power minus 1 gives us that. Perhaps, how did I work it out? Do you know what a factorial is? Now note that n factorial means n into n minus 1 into n minus 2 times 1 times 3 times 2 times 1 dot, dot, dot there. So if I've given you 2 factorial, it's called a factorial. So if I say 2 factorial, it means it's 2 times 1, which is 1, which is 2. Now, if I've got 3 factorial, is 3 times 2 times 1 is 6. If I've got 10 factorial, it's 10 times 9 times 8 times 7 times blah, 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 the last one times 3 times 2 times 1. I can even simplify a factorial. If I've got 10 factorial over 9 factorial, this is the same as 10 times 9 times 8 times blah, 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 all over 9 factorial, it's 9 times 8 times 7, blah, blah, blah. All these terms will cancel, and you'll see that the answer is what? It's 10. So that is how I manipulated that. So in order to expand this 1 plus d to, yes, sir.
Angithi i-factorial
Injani?
u-factorial ukhona
Calculate, yes, you do. I was just showing you that you can manipulate it. So 10 factorial is there in your calculator. I think it's expressed as n factorial, so you can work it out. So how I worked out this expansion here and end up with that, in other words, that is how I calculated it. So therefore, Let us go back to the problem. Therefore, 1 plus d to the power minus 1 acting on x squared gives us the expansion of that, which I said it was what? Bracket 1 minus d plus d squared minus d cubed plus d to the power 4, perhaps up to infinity, close that, acting on x squared. What we have done now, this thing here initially did not say anything to that x squared, but because we have expanded it, now it is talking to that. Now let us make it talk. What is 1 on x squared? So it's 1 times x squared. That becomes x squared minus. What is d on that? What does d says on x squared? It says find the derivative of x squared. Derivative of x squared is what? It's 2x, so it's minus 2x. Then the next one, it's d squared on that. So it's the second derivative of x squared. The second derivative of that is what? It's 2. What is this one? This one says the third derivative. If we take the first derivative, it is what? It's 2x. The next one, it's 2. So to find the next one after that one, after the second one, it will be the third one. So we'll be differentiating 2. What is the derivative of 2? It's 0. The next one higher than that is 0. And even this one, it's 0. Why is it 0? Because we are taking the third derivative of something that is smaller. This is smaller than that. So its derivative will always be 0. So your final answer here is what? Is x squared minus, sorry, is x squared minus 2x plus what? Plus 2. That is our final answer. Sure.
Ngicela ukubuza la ukuthi kumele kuze kuba ukuthi uma si derive sithola i-answer e-0.
Yes.
Okay.
Uma kunjani? Uma differentiate, we obtain a 0 as an answer. Then what?
Kuyobe sekuphelile.
Yes, kuyobe kuphelile. Yes.
Okay.
If I get you, please.
Sorry,
Next
sir.
one. Let us look at this one. Yes.
Hey, bezicela bandla usinikeze like ama-guidelines because abanye bethu bakubambe usuqalile se bamane bayisenda nje ilink besingazi ukuthi sineclass le-maths manje sikubamba nje usuphathi nendawo asazi kwenzakalani.
Okay. What we are doing here, we started with operator D. I have a class again at 11. So we have started with operator D. Operator D is the method that we are going to use in order to solve differential equations. So all the differential equations that we have seen so far, we can always subject it to operator D. What we are doing now, I'm just giving you the background or the theory behind operator D, how to handle it, what to do, theorems that goes along with operator D. At this point in time, we are still at the early stages of operator D, whereby we must learn how to handle the notation that we use. If it is like this, how do we go about? Once I've exhausted everything under operator D, it is then that I will have a differential equation written in operator D format. Then thereafter, we will solve using all the methods and techniques of operator D that we will have acquired then in order to solve that particular differential equation. Right now, we are right at the bottom of operator D, how to handle it, how to evaluate, how to do whatever using operator D. This is what we are doing right now. Okay. And D means what? Yes, D means what? Differentiate. It stands for dy over dx. And 1 over d means integrate. So if we don't have that, as it was the case with the previous example, we must try and manipulate whatever that expression we are given such that there is d and what? And 1 over d. Until we have that, then we will be able to find an answer to that. Let us have a look at this one again. This one here says it's 1 minus d. Remember, the first one was 1 plus d. All my terms there were 1 minus d plus d squared minus d cubed. Now, let us have a look at this one. It's a matter of changing the signs. If I were to expand 1 minus d using the same notation, binomial expansion, I will get the terms as follows. 1 plus d squared plus d cubed plus etc. 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 Now, because of the previous example, I know where to stop now. I will stop at d squared because the highest power here it's d, it's x squared. So I can't differentiate more than the power here. So I will stop here at d squared. But you'll see that becomes what 2x squared here. This gives us. Now, is this talking to that? Yes. What is 1 times 2x squared? Is just 2x squared plus. What is d on that? What is the meaning of d? D means differentiate 2x squared. What is the derivative of 2x squared? It is 4x. What is this on that? The second derivative. I've already differentiated it once more. So it means I'm differentiating 4x. What is the derivative of 4x? Is what? It's 4. Just as for checking, the third derivative. Now, this 3 is bigger than that. It has to be 0. What is the derivative of 4? Because 4 was that of the second derivative. Derivative of 4 is what? Is 0. So the answer is that. So in other words, if we're given x squared here, so we'll have to stop at d squared, e.g. Next example, 1 plus d acting on what? On x cubed. What will be the expansion of 1 plus d, so to the power minus 1 there? Now we know the terms now. If it is 1 plus d, the terms are 1 minus d plus d squared. D squared, the next one is d cubed. After d cubed, I'll have to stop there, is it? Because this x here is to the power 3. I can't have a derivative of higher than that. So I'll stop there into what? Into x cubed. I think there's a sign missing here. It's minus d plus d. This one is minus, nah? This one is minus. Now let us apply that. What is 1 times x squared? It's just x squared. What is d on that? It is what? It is plus 3x squared. What is the second derivative of that? In other words, I'm differentiating that once more. Is what? Is 6x. What is the third derivative of that? Is what? Is 6. If I were to take d to the power 4, it will be the second derivative of 6, which is that. Yes? Sorry, minus here.
Is it plus or minus?
Sorry, minus.
Minye nale 1 times x cubed mase kuba x cubed.
Yes.
Thank you.
Right, that is x cubed. Okay. So next example. Let's say it is, let's say we have 1 minus d to the power minus 1 on what? On x to the power 4. You'll tell me where to stop. What is the expansion of that? It's 1 minus d. All the terms are positive. But when it is 1 plus d, all the terms are what? Are negative. So it's 1 plus d squared plus d cubed. In Kubege, I'll stop at d to the power 4 because my x is to the power 4. Plus d to the power 4. Acting on what? On x to the power 4. Now, there is a communication. This on that is what? Is x to the power 4. This on that is the first derivative. It's minus 4 what? X cubed. Second derivative is minus 12x squared. Third derivative, it's plus. Third derivative, it's minus what? What am I doing? They're all positive. So So it's plus 24x. Then the last one, the fourth derivative is what? It's 24. I hope you can say that now. If I were to take d to the power 5, I'll get 0. Are you with me? Yes.
According to their code, my sign.
Negative, only positive.
1 minus d. I'll take you back. According to what I have done here, 1 plus d, I obtained the expansion terms will be, my sequence is 1 minus d plus d squared minus d cubed plus d to the power 4. Jalo, jalo, jalo. If it was 1 plus d. If it is 1 minus d, all my terms are positive. It's 1 plus d squared plus d cubed. How do I obtain that? I am using this binomial expansion, the one that I gave you here. Perhaps as an exercise, just go home and apply that on 1 plus d and 1 minus d. So if it is 1 plus d, my terms alternate. One is positive, the next one is negative. The next one is positive, the next one is negative. But if it is 1 minus d, if it is 1 minus d, all my signs are what? Are positive. So it's 1 plus d squared plus d to the power minus 3. Perhaps let me write that down. Note. So if you've got 1 plus d to the power minus 1, your terms alternate. It's 1 minus d plus d squared minus d cubed plus etc., 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 depending where you'll stop. Next, if it's 1 minus d to the power minus 1, note I'm using 1 as a and n as minus 1 for the time being. It's 1 if it's 1 minus, so it's 1 plus d squared plus d cubed plus blah 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 blah. In some cases, because it won't always be 1 and minus 1. If it's something else, then or else use a plus b to the power n. It's a to the power n plus a to the power n minus 1 times b plus what? It's easy to build. The next one is built from the previous one. It's n minus 1, a to the power n minus 2, b squared all over 2 factorial plus dot dot dot. But the most easiest one is that. So in other words, this and that one are the ones that we'll always gear for. In other words, we'll say if the teacher can actually give us 1 or 2, then it will be easy for us. Let us have a look at the next example. Next example will be, perhaps it's slightly different. So we have 1 over d squared plus 2d acting on what? On x squared. Again, we have a case whereby the communication here is not right. We are supposed to have d or 1 over d. In this case, we don't have that, but we can simplify the bottom or the denominator as 1 over, from the denominator, we can take d as a common factor because 1 over d is known to us. Then I'm left with what? Then we are left with what here? D plus what? Plus 2. Am I right? Yes. Acting on what? Acting on x squared. That is what I'm left with. Why am I taking d out? Because 1 over d is known. What is the meaning of 1 over d? It means integrate. Am I right? So that is known to us. Next, we look at d plus 2. So 1 over d is known. That I can write it as 1 over 2 plus d. 2 plus d acting on what? On x squared. I've just changed the right denotation there. That will give us 1 over d times. Now 2 plus d, we did not expand that. We expanded 1 plus d, am I right? Or 1 minus d. We did not expand that. But now I can write this this 2 to be 1. So that is 1. I can take 2 as a common factor here. If I take 2 as a common factor, I'm left with 1. Then here I'm left with what? With d over what? Over 2. Acting on what? On x squared. So in other words, 1 plus d over 2 is this part, where my d now, this d is d over 2. Let me write this quite clearly. So it's 1 over this 2 times d is what? Is 2d. Shooting no balana, no 1 plus what? D over 2. Close that. Let me bring that. Acting on what? On x squared. Now, do you see this d over 2? It is this big D. So this I know this expansion, 1 plus d over 2. It is that expansion. It's 1 plus. Just that my d is d over 2 here. So the term that comes out of that, I still have 1 over 2d outside. The terms will be 1 plus d. The first one, it's 1. Next one, it's minus d. But my d is d over 2. I put a small bracket there. Next one is going to be what? It's d over 2 what? All squared. Am I supposed to stop here? Yes. Why? Because this x is to the power 2. So the second derivative will stop at d squared here. Then acting on what? On x squared. Questions?
Sorry, sir.
Yes.
Sorry, sir. Ukubuza ukuthi lo 1 plus d over 2 umthathile wamisa kwi-numerator then wa apply binomial theorem.
Yes, my friend. Yes. In other words, okay. In other words, from here, Gazoti, it's 1 over 2d into 1 plus d over 2 to the power minus that, acting on x squared. Just that I skipped that step. Okay. Right. Next, here. So it's 1 over 2d. Then let us apply. What is 1 on that? That is x squared. What is d over 2? D means differentiate. Don't forget we have a 2. What is the derivative of x squared? It's 2x. 2x over 2 is what? It's just x minus x. Then this is d squared. This will be over 4. So the second derivative of x is what? It's minus 1. It's 1. So it's going to be plus 1. But this is over 2 squared. That is what? Over 4. Next, I apply what is outside. 1 over 2 is outside there. But what is 1 over d on that? 1 over d means what? Integrate. Integrate. What is the integral of x squared? It is x cubed over what? Over 3. What is the integral of x? It's minus x squared over 2. What is the integral of this constant with respect to x? It is what? X over what? Over 4. And this is your answer. Are there any questions? Digest it, good people. So what we are doing here, when we are given a big chunk of a differential equation, which will take about plus minus 4 pages, we will be asked to solve that differential equation using operator D methods. All these things that we are doing here will come back before we can actually find an answer. So, as I said earlier on, different differential equations are solved using different methods. This is one of the methods. The next method after this one is the one which is called the Laplace transform method. Again, I will start by defining what is a Laplace transform, properties of Laplace, how to take Laplace. And then at the end of the day, I give you one big problem from perhaps an electrical engineering perspective, perhaps an electric circuit, whereby we are given, whereby we are applying Kirchhoff's rules and all those things. And then we solve that. We'll apply that Laplace transform, and then we find the answer, and then possibly sketch the graph. So at this point in time, we are still gathering information in as far as how to solve the Laplace transform is concerned. I mean, the operator D is concerned. Let us have a look at the next example.
So,
Yes, yes.
bengicela ungichazele lesi step la after la sekukhona khona 1 minus d over 2 no d over 2 squared.
After sekhona ubani u1
Lesi step sesithathu maswekugcineni.
1 2 3 oh here right. Now it comes from here. Note mina ngazi le expansion 1 plus d to the power minus 1. Angithi ngiyayazi angithi. But now kule case yami ngino 1 plus d over 2. It means this d use ubani use d over 2 lo d lo. Ama terms ala azobuba azobefana awu1 kusho ukuthi udinga ureplace ngo d over 2 1 minus d over 2 ukube bekunormal this was going to be d. The next one is plus d over 2 what all squared. Next blah 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 blah. So my d here kuzoba 1 minus d plus d squared use ubani use d over 2 njalo. But it's the same expansion. That is what I did there. Okay.
Yes, sir.
We look at the next example. Please, good people, we must grasp this thing right from the beginning because it's very important going forward. Let's look at this one. Next one. It is 1 over d squared plus d minus 1 acting on what? On 2x squared. So this is plus d there, plus d. Now again, if you look at this outside expression, it is quiet to that. Remember, there must be a communication. The communication will be d or 1 over d. So if it is not like that, it means we need to do something until this outside term says something to that. It's either d, which means differentiate, or what? 1 over d, which means integrate. As it is here, it is just quiet. But at the back of our mind, we know 2 expansions. The first one is 1 plus d to the power minus 1. We know that one precisely. It's 1 minus d plus d squared, njalo. The second one is 1 minus d, which is to the power minus 1. The expansion is 1 plus d squared. So we'll try and play around with that such that it gives us something that is known to us precisely. Let us see. If I look at that, there are no even factors for that one, but that can be written as, I can rewrite it as 1 all over, at least there is that 1, minus 1 plus d squared plus d acting on what? On 2x squared. That's okay. I did not do anything. I wrote it in a different format. I started with 1, minus 1, because I know those 2 expansions, 1 plus d, 1 minus d. Next. Now it's 1 all over. But my expansion does not have a negative. They are always having a positive 1. So I take minus 1 as a common factor. I take minus 1 out as a common factor. If I take it out, I'm left with 1, which is okay for the expansion, but the signs inside here, they will change. D squared minus d acting on 2x squared. There's nothing wrong if I do this. It's still okay. But now, I still have to work out that. This can be written as 1 over minus, that's minus just 1 all over what? Bracket 1 minus. Look at my d's. All my d's are now negative. I can take a minus out as a common factor again. Then I'll be having d squared minus plus what? Plus d. Close that. I group the d's. Negative d squared. I group them and pull out minus 1 as a common factor. So that I have that expansion. Now you can see that this is my big D, which is this expansion. takes me back to this expansion or that expansion. So my D now is no longer D, it is D squared plus D, right? So we can expand that. So now let me write it neatly. This is just minus 1 all over. Please bear with me, my hands are not, that's mode 1 minus bracket D squared plus D kanje into 2x squared, and which can be written as minus 1 minus D, so it's 1 minus D squared plus D bracket minus 1, which is known is 2x squared. What are the terms that gives us that? It's minus into. Now this is 1 minus my big D's, the whole lot of the D's. This is my big D. Okay, so my big D, the one that I had earlier on, is replaced by D squared plus D, of which the expansion is known precisely. What is that expansion? The first term is 1, mind you, it was minus. If it was 1 minus D, all the terms are positive. 1 plus what? D squared plus D to the power 1. Next is what? Is D squared plus D to the power 2. Am I supposed to stop somewhere? Yes, the index here is what? It's 2. So the highest power will go up to D squared. Close that into what? Into 2x to the power 2. Move on, minus into 1 times 2x squared is just what? Is 2x squared. As apply again. D squared, second derivative of that. First derivative is 4x. Once more is 4. It's 4x. Once more is what? It's 4. So that is the second derivative. The first derivative is what? It's 4x. But D squared plus D all squared. D squared plus D all squared, you square the first term, is D to the power 4. Next one, twice the first and the second term, is 2D cubed. The third one is D squared. All these one will give me 0 because they are bigger than that. So I'm not worried about that. The only one that I'll get here is D squared, the second derivative of that. The second derivative of that was what? Is what? It's 4. So the answer here is minus into. Minus is what? Is 2x squared. 4 and 4, that's 8. I write it 4x first, then what? Plus 8. That is my answer. Question?
Sorry, sir.
Yes.
Yeah, but le brackets lokuqala uma uqala nase uvula ususa ama brackets lapha nguphi answer efanayo.
Okay, give la.
No, lapha ezansi mo le steps esibili muqhamuka ezansi.
La.
Yebo, uqala uvule ususe lo ma brackets lawo bese ke uya differentiate ke usahlanganisela.
Yes, indifanayo. Yes, indifanayo mnganami. Mina bekukhombisa ukuthi lo D squared plus D umele u-D. Angithi ukube ubengekho lo D squared plus D, bekuzoba u1 plus D plus D squared. Uyabona leyo? Ngizama ukukhombisa ukuthi lo D squared plus D stands for big D, D to the power 1.
Okay.
The next one is D squared plus D all squared if this was D. Manje u-D wami use u-D squared plus D. So my D is what? Is D squared plus D.
Yeah, right. Yeah.
Sure.
Sorry, sir.
Let's see whether we
Sorry,
can.
sir.
Yes. Yes.
Ngicela ulento ozungitshele lo 8 ukuthi uphume kanjani?
So 8 lo. And what is 4 plus 4 nganyama? 8.
Okay, so ngingabonanga.
Yeah, first derivative and the second derivative yalenda ngithi. But ngi-expandile lokho enginikeza leyana. But the third derivative yakhona and the fourth derivative will give me 0. Okay. Let us see whether we can look at the last one. Oh, the last one will be. The last one will be 1 all over D squared plus what? Plus 1. The action is on x squared. Right? What is it that we know? We know the two binomial expansions, which are easy for us, which I think you must always have that in your mind. 1 plus d to the power minus 1, or 1 minus d to the power minus 1. You must know their respective terms. Let me rewrite this as follows. This is 1 all over 1 plus d squared. That's one and the same thing, acting on what? On x squared. Now, this can be written as 1 plus d squared all to the power minus 1 acting on x squared. Now, again, mina ngazi d, but also good d squared. The same thing goes on. 1 plus d. What are the terms there? The terms will be 1 plus minus. Now, my d is d squared. So it's d squared, my first d to the power 1, if you can write index 1 there. The next one is plus, because the terms alternate, plus d squared, d squared. I will have to stop there because this is to the power 2, acting on what? Acting on x squared. Okay? If that is the case, I can evaluate what is 1 on x to the power 4. 1 on x to the power 4, so it's 1 times x squared. I'm sorry, x squared. So it's just what? It's just x squared. What is that? D squared, second derivative. Derivative of x squared is 2x. Once more, it's 2. So that becomes minus 2. Now, this will be d to the power 4, which will be 0. So our answer here is x squared minus 2. Okay. Are you still okay?
Yeah.
Ulahlekile kanyama.
Ngicela ukuthi sibuye kancane lapha phezulu kancane lapha phezulu. Yeke lokho kuyenza manje example leyana lebe ngibuza ukuthi 8 phume kanjani. Ngicela ungibuyele lapha ya udlule la phezulu unyuke.
Yes.
Ya lapho uthi kwenzakaleni lapho ukuze sibe lapho kanene.
Ngithe mina yini mina engiyaziyo mina ngazi lento mina sibele emuva. Hayi into engiyaziyo mina. Ila my expansion 1 plus d to the power minus 1. No 1 minus d to the power minus 1. So manje konke engiyezwe kona, I will always try and express it in terms of what I know. Yebo leyo. Now, gino la 1 minus bracket d squared plus d. Sengizothi d squared plus d useyi-d wami wonke ngoba ngiyazi 1 minus d ubani. Yebo leyo. So, yes, sengizothi-ke maku-1 minus d, all my terms are positive. So 1 plus d squared. But now my d is d squared plus 1, which is my first d, this one. My next one is d squared plus d all squared is the next one.
Yes.
Yes. Good people. I don't want to go far.
Ngifuna uqhubeke from leso step kahle kahle ukuthi uphume kanjani kube khona u4 no 4x. Ngifuna leso step.
Okay, asiqaleke la. What is 1 times 2x squared is 2x squared.
Yes.
This is alana. D squared on that second derivative. What is the first derivative? Is 4x. Once more, it's 4. Now, next, singular. D on 2x squared is the first derivative. What is the first derivative of 2x squared? Is just 4x now. Singular. Leya to d squared plus d all squared. Inginikeza d to the power 4, 2d cubed plus d squared. D to the power 4 on 2x squared will be a derivative of not. But in nalo d squared. Over now, second derivative of that. First derivative is 4x. Once more, it's 4. That's again like terms. 2x squared, now you have 2x squared. 4 and 4 is 8, then 4x now.
Oh, thanks, sir.
Right. Okay, sure. At 11, good people, may I just stop here so that you'll digest it properly? At 11, I have a class again with another group. You can join me again. Okay, I'll be starting again with this section with those students again.